This video is an extension to the Making Bowls tutorial, and in this example we're going to look at how we can use the new Spin tool to create a two-sided spun bowl in Aspire. So the Spin tool works like this. You draw a cross section and then you spin it using the Spin tool, and it will create a circular shape that takes on the profile of the vector that you use to spin, like so. For the bowl, we want to create a similar ripple shape that recesses into the original shape. So to do this, we simply copy the vector to the other side, and we're going to look at reducing the height of the part by bringing the leg up by 1/4 of an inch and then removing the span on the other side. And then what we'll do is we'll line the vector up to the bottom of the leg on the other side, and we will ultimately be able to visualize the thickness of the bowl that we want to make, which would be 1/4 of an inch thick. And then using the Spin tool, we can only spin the part around the left side of your vector cross section. So we need to ensure that we position it so that the left side is at the center of my job that matches the original vector on the other side. So then we'd spin that, and you'll see it will create a positive shape that would look like this, and then all we'd need to do is just alter the combine mode so that it's subtracting, and there we have our bowl. So let's show you how to do this in the software. So we're going to go and create a new file. We're going to work with a double-sided job, set our width to be 8 inches, height 8 inches, material thickness we're working with is 2 inches there. I'm going to set my Z0 position of the material surface for the top side, and I'd like to reference that top side for the bottom side, so I'm going to use this option here to zero off the same side. So for the top it's the material surface, for the bottom it will be the machine bed. XY datum position in the lower left hand corner, I'm going to flip that from left to right in this direction. I'm going to work with a very high modelling resolution, and then we could go ahead and press OK. So we're going to begin by creating the shape for the underside of the bowl, and I'm going to do that on the bottom side of my job. I'm going to draw a circle to help determine the shape of my bowl. So I'm just going to locate the centre of the job. Okay, so you can see I've got my snap lines coming up there, the vertical and the horizontal centre. And I'm just going to pull a circle out, and then using the transform shortcut keys on the keyboard, I'm going to type in 6.5 followed by the letter D for diameter, and that's going to create a circle that has a diameter of 6.5 inches. So this will ultimately be the outline of my bowl. I'm going to use this as a guide to create my cross section. So as I mentioned in the introduction, to create a spun shape we need a cross section that we spin around the left end point. So I'm going to go into the polyline tool, and we're going to draw a cross section from the centre of our job going over to the right hand side to cover the radius of the bowl that I want to make. So starting at the centre ensures that when I come to spin my part, it's going to spin that around the centre to create the shape. I'm just going to go up by 1 inch so I can see the length there is displayed as 1 inch. So I'm going to click that in place, come over to the right hand side. I want to make sure that we keep that in line with the outermost right side of my circle. So I'm just going to wake that point up here. I'm just going to go back on myself. You can see I'm just following that line. I've got my snap lines there, so I can click that in place and I know that I'm in line with the right hand side of the circle, and then I can click to finish that so it's in line with my original start point over here. So let's right click to come out there, and here we have a basic cross section, and now we need to edit that. So let's go into node edit mode, and we'll just zoom in a little over here. What I'd like to do is ensure that I have a flat bottom of my bowl. So I'm just going to insert a midpoint here, and then insert another midpoint between this node here and this node here, and this area will form the flat part of my bowl. I'm going to delete this node. This will make a little bit more sense when I come to create the actual curvature. Over on the leg here, I'm going to right click to insert a midpoint. So that midpoint will be at 1/2 inch high, because we know that when we drew our cross section, we drew it so it goes up by 1 inch. And then I'm going to right click between this node here and this node here and insert a midpoint there, so I know we have a span that is 1/4 inch high, and we'll use that later on. So I'm just going to delete this point here, and we're also going to delete this point here. So here I can just go ahead and press I on the keyboard to insert some points like so, and then I'm just going to box select these 3 nodes and then press S on the keyboard, and that will smooth them out. Here I want to take this handle and keep it in line in X with the node that we've got here, and I'm going to take this smooth point and I'm just going to bring that around just to create some curvature. We'll do the same over here, so just creating a little bit of a wavy pattern here. And then over to the right hand side, I want to ensure that we keep that inside of our circle there, and I'm going to pull on this handle so it's aligned in X like so, and again we're just going to move that over so that it sits within our circle. Okay, so that is our curvature for the underside of our bowl. Let's just press F to fit that to screen. I may want to just tweak that a little bit, so in node edit mode I just want to bring that across, maybe pull that down a little, and we'll do the same here. Maybe put it up and put it up there just to create a little bit more curvature there. Okay, so I like what we've got there. Right click to come out of node edit mode and just press F to fit that to the screen. So now I'm going to draw some circles that represent my dowel holes. So my dowels I've measured up, they're 0.33 in diameter, so I'm going to type that in. So 0.33D, and that will create that for me. And I could just go around and input the other holes like so. Okay, so let's close that down. So now we're ready to actually model the cross section. So if we just tile our windows, I'm going to take that cross section into the modeling tab, and we're going to go and spin this shape. Before I do that, I'm just going to right click on the level just to rename that. We're going to call that one model, just so it's organized, and then with that vector selected we're going to go into the spin tool. So here we're going to use the spin option, so it's going to spin that around the left end point. We'll give that a name, we'll call this one underside, and then simply press apply, and there is our spun shape. Perfect. So let's just close out there, and then we'll put this in Z. And before we go ahead and copy our cross section over to the other side, I'd just like to take this dowel, just move it a little bit in to our job so it's not too close to the edge of our part, and with that selected we're going to hold down shift, select those dowels, shift and select the cross section and the outer circle, and then we're going to look at copying all of those to the other side. Let's right click, use the option here, copy to other side, and then we're going to go switch to the top side here. And now we're ready to alter the cross section so that we can create the recessed shape into the bowl that we already have so far. Okay, let's put that back in Z. And so as we're creating a recessed version of the original cross section, we just need to tweak it a little to make it a little smaller in height. So I'm going to take that vector, go into node edit mode, and here I'm going to take this node and I'm just going to start dragging it up the y-axis, okay, and then I'm going to type in 0.25 and then I'm going to press enter, and that will move that node up from its original point by 1/4 inch. Okay, so we took 1/4 inch off that leg there. You'll remember when we originally created this vector, I did it so that this point was at 1/4 inch high. And so all I need to do here is just look at deleting this span here, and we should be able to see that the two line up, and we can see that there. So just bring that back to its original point, so we know that we've lost 1/4 inch on each side of that cross section. Okay, let's just right click to come out of node edit mode, and now what I'd like to do is just align the bottom of this vector to the bottom of the original vector on the other side. So the really nice thing about putting this in multi-sided view is that I can actually snap to geometry that is on the other side. So you can see I'm actually snapping to the midpoint of my job, but I am able to snap to various parts of my original cross section like so. So I'm going to put that to the centre of our job. And so here, like you saw in the introduction, what we're actually seeing here will be the actual thickness of our bowl as if we was to cut it in half. Okay, and so that is our thickness, and it should be 1/4 of an inch because that's how much we chopped our vector up by. So we got rid of the span over here and we brought the leg up by 1/4 of an inch. Okay, what I need to do is just tweak this again to ensure that the cross section over here, if we put it into node edit mode, I'm just going to insert a new point there. I'm just going to make sure that that touches the edge of our circle so that it's at the same width as our original cross section. Perfect, so we pretty much have everything ready to spin our new cross section. Remember, we spin about the left end point, so if we was to do this now, it'd spin it from this point here. So we just need to send this over to the right hand side of our job, and so we're going to select that vector, hold down shift and then press H, and that will just send that over horizontally like so. So now we're ready to go and create that dish shape. So let's go to our level. We're going to right click, rename that level. Just going to call that one model. Again, just like to be super organised and organise my levels with relevant or appropriate names. Okay, so there we have our shape. Let's go into the turn and spin tool. We're going to spin that. We're going to call this one recess. Press apply. We can see that it's taken shape there. It's currently adding. So what we can do is just simply set the combine mode of that to subtract, close that out, and then if we just go ahead and maximize the 3D view, we can see our finished bowl there. So let's have a look at that bowl. It might help if I just temporarily switch off the modelling plane, and we can see that is the recess, and we can see we've got the underside of our bowl here. So we're just pretty much putting that ripple inside of the bowl based on the outside profile, and that looks pretty cool. Another cool thing to note here is that if I hold down Control on my keyboard and run my mouse over my model, you can see at the bottom right there it's displaying the actual thickness of our bowl. We can see that that is displaying pretty much 1/4 of an inch all the way through, and that's down to the fact that we altered the vector for this side where we shrunk it down by 1/4 of an inch to create that thickness. Okay, so let's just put that in Z, and then we'll go ahead and tile our windows. So now I need to think about adding tabs to our bowl to hold it to our material block. So I'm going to position the tabs on the underside. So let's go to the bottom side there, and then I'm going to insert a new level, rename that level. I'm going to call this one tabs. I'm going to set the combine mode of this level to merge so it blends in with our underside component. And in our clip art tab, in the 3D tabs, we've got these rectangular tabs. You could make them yourself if you wanted to. However, you may sort of take advantage of the free 3D tabs that comes with the software. I'm just going to put that up to the top there. Okay, the tab is 1/4 of an inch thick. So if you take a look at that, you can see that there. And I'm just going to position this tab in a circular array. So we're going to array around the centre. I want 4 copies. We'll group those copies, press copy, and then it will input my tabs. Perfect. Let's close that down. So now we're pretty much at a stage where we can go and run our toolpaths. So let's switch to the top side, and then we're going to go and switch over to the toolpaths tab. So let's go into the material setup. So here we can see we've got a material thickness of 2 inches, XY position is in the lower left hand corner. We're going to set the Z0 for the top side on the material surface. And to position my model within the centre or the middle of my material block. Okay, so I'm going to have a gap above half and a gap below of half. Check over the rapid C gaps, home start position, ensuring they're all safe and appropriate, and then we could go ahead and run our first toolpath. So we're going to start by creating our dowel holes. Okay, so I'm going to take those vectors into the profile toolpath. We're going to cut 3/4 of an inch into our material block. I'm going to use a 1/4 inch end mill. We're going to machine on the inside there. We're going to give this a name. We'll call that one Profile Dowels. And then we could simply press calculate, preview that, and there are our dowel holes. Let's close out there. Now we're ready to run our 3D roughing toolpath. So in the 3D roughing toolpath, just like the other example, we're just going to go through some basic settings here. So we're going to use a 1/4 inch end mill. We're going to go and use the model boundary as our machine limit boundary. So it's going to look at the model and use that as our boundary. We'll put in an offset here of 0.125 in there, so it's just going to roll past the edge of our part by this amount. Machine allowance of 0.04, that's just going to enable us to leave a small skin of material there for our finishing tool to cut at. Then we're going to go and do that in a Z-level strategy where we're going to raster in the x-axis, give that a name, just simply call that 3D roughing, press calculate. That's just going to calculate that for us, and then we can open up the preview there. So the preview toolpath form is now open, and we can preview that toolpath like so. Okay, so you can see all the steps there. That looks pretty good. Let's just put that back in Z. Close out there. I'm going to run our 3D finish pass. This time we're going to use an 1/8 inch end mill and use the model as the boundary. Put in an offset of 0.1 in there. Use the offset strategy, so it's just going to go round and round. And I'm going to put in a small step over retract of 0.02 just to eliminate the tool markings that we may have every time the tool goes into the next contour. So it's just going to lift instead of just travelling straight to it. Okay, let's just go ahead, give that a name, call that 3D finish, and then we'll press calculate. Okay, so it's just going to work that out for us, and then we could simply go ahead and preview that toolpath. Okay, so I like what we've got there, looks good. And so now we're ready to go and machine the bottom side. So let's just close out of the preview toolpath form. And then we're going to go and switch over to the bottom side. So at this stage, what we need to do is take our dowel vectors and we're going to drill them into our spoil board to create our location holes. Before we do that, let's just quickly glance over our setup to ensure everything looks okay. Okay, material thickness XY is in the lower left. This time we're setting the Z0 off the machine bed for the bottom side. And again, that's just so that we're constantly referencing from this same face. Model position in the material is in the centre, and everything looks okay here. So we're going to take those vectors for the dowels, and we're going to take them, go into the profile toolpath. So start depth for this is going to be the material thickness. That's going to be 2 inches, and we're going to cut down 1/2 inch into our spoil board using a 1/4 inch end mill on the inside of those vectors. I'll call this one profile dowels, no material spoil board, just to remind myself that we are machining into the spoil board here. Okay, and then we'll press calculate. It's going to warn me we're going to cut through the material. That's okay, as we are just cutting straight into the spoil board in this operation. So if I just flip my block over, you can see it's coming down by 2 inches, and then it's going to begin that cut to cut in to my spoil board by 1/2 inch. Perfect. Okay, so let's just put that in Z. I'm not actually going to preview this as we wouldn't actually machine into my material block. This is purely for the spoil board to create our location holes for when we flip our material over, we get correct alignment. So let's just close out there and we'll just undraw the visibility of that toolpath. So now we can run the 3D roughing toolpath. So let's go into the 3D roughing toolpath. I'm going to use a 1/4 inch end mill again. So this time we're not going to use the model boundary as our machining limit boundary, as that will cut out our tabs. So we're going to use the selected level, and we're going to use the model level, and so it's going to take the underside component as the actual boundary, but any components that go into that boundary will also be included, so that's our tabs here. Also going to put in an offset there of 1/8 of an inch so it rolls past, a little bit past the part. Machine allowance again 0.04, and then we'll go with a Z-level strategy where we're going to raster in the X-axis, give that a name, call that 3D roughing, press calculate. And so we are pretty much just running the sort of same settings for our toolpaths here, and we'll just preview that toolpath. Okay, we can see it there, we can see our tabs are firmly in place to our block of material. We're not cutting those away. Close that out, go back into the 3D finishing toolpath. I'm going to use an 1/8 inch ball nose here. Again, we're going to use the selected level, I'm going to use that model level, put in a small offset of 0.1 so the tool rolls past. I'm going to do that in an offset strategy, put in a small retract of 0.02, call that one 3D finish and press calculate. That's just going to run that for us and then provide us with a preview where we could then preview that toolpath and see how the part would actually look when we come to cut that out on our CNC. So if we maximise the 3D view and take a look at the part, we can see that it hasn't actually cut all the way through the two sides, and that goes down to the fact that we are using a rounded tool to finish the part, so we will be left with cusping as only the centre of the tool would ever reach the bottom there. And if I just hold down control, you can see that we have a very teeny tiny thickness there. So we're just going to look at introducing a negative plane just to drop that tool so it cuts through and will ultimately remove that cusping effect. So let's just close out here, and I'm just going to switch over to the drawing tab. We're going to tile our windows, and then on the bottom side I'm going to right click on the model level to insert a new level, and then we're going to rename that level. I'm just going to call this one limit plane, and then we're going to set the combine mode of that so that it's merging. So I'll just right click there, set the combine mode to merge, and then with that level active we're going to create a zero plane, and on that zero plane we're going to go into the properties here. We're going to put in a negative base height, just something very small, 0.05 in this case, and then we'll just close out, switch back over to the toolpaths tab, go into our finishing toolpath, calculate that now that we have that plane in place, and that should enable us to cut through and eliminate that cusping. So if we do that, we can see that that has done that for us. Perfect. And so there, with our bowl toolpath, and we're happy with the preview there, we could then simply go ahead and save out our toolpaths. And you could just use the save toolpath option to save out both sides of our part. And so that completes this tutorial. And so let's go ahead and save the file. So go to File, Save As, and we'll call that one Spun Bowl, and you can access that from the project folder. Okay, so that completes this tutorial. Thank you for watching.